recording in progress, and we are just going to use something to get some information. Okay. I will just let me see. I will create something HTML and CSS. It will not difficult what I will do, and I will just say shop. It's not important what. One question. Uh, did you already check what is promises and assign away in the previous class? I'm sorry, the last 2 weeks I am a little bit disconnected and just coming over here. Did you cover this part? Into my notice, it has to be covered here and here with Asamat and with Manner, if I am not mistaken. But if I am mistaken, you can tell me and I will start from the beginning. If not, I will just go over it like briefly. Someone can help me over there. For example, um, Amantu is correct. You already covered these promises assigned away.
Sorry, can you repeat again?
Yes. Okay. Are you able to see my screen?
Yes, yes.
Do you see what is in this moment selected?
Yes, promises?
And assigned away. Did you cover this one in the previous classes?
Yes, yes, we covered it.
Okay. Would you mind to tell me what do you understand about promises?
Promises is like we are putting some array just to wait some data from backend side, and after that we will use it.
Okay, yeah, that make sense. Okay, it's going to happen in the future that we don't know right now, but it can have different result, right? In this case, a promise, the majority of time has to be related with the backend. And why do we use, in this case, promises? Mostly because we are not sure what is going to come in this case, from the backend, right? Sometimes we don't know what is going to arrive from the backend. Which are the possibilities of the promises? Which kind of response we can bring from the promises? Like when you create a promise, what type of response you can expect to have? Someone can help me like in that one?
Are you asking about the JSON or response? I when we get response, we need to convert the JSON. But what was your question?
Yes. For example, when you create a promise, right? And you create the promise, and mostly when you are using fetch is a promise, right? It's a promise. It's something that is going to be resolved in the future. But that result, what kind of result could be?
No.
For example,
Asynchronous, or what is that? Oh, something like that.
as,
I'm not sure about
asking,
the English version.
yeah, I like asking away. I understand in this moment, but a promise can be resolved or rejected, right? Like a promise can be resolved, or in this case, let me just write it here. Yeah, I will write it in the chat for you to have it. And these are the three states that we can have in a promise. For example, let me just get an API and shop, fake shop. Okay, fake shop API. Okay. Well, this is just an API that I will be using just and just to have it. This is the API. This is the API. Don't pay attention mostly what I am here, but here it is. Most of the time, when you have this shop, you create something that a promise could be something like a fetch, right? You use fetch and you get some information. Look, if you see here, a fetch create a promise. For example, here, yeah, you create a promise. And I can even add it here. Cons my fetch. My fetch. Yeah. And I will just console log. Console.log and my fetch. Let's save it. Let's run it. And if we go over here, look, here you have a promise. Every time that you are using fetch, fetch in this case is considered an API that creates a promise. That promise, why we call it a promise? Because we don't know the result. The result can be pending, like right now, is a promise that is pending. Why? I send a request. I am saying, hey, fetch, go and bring some information from the backend, right? That is what, in this case, Amantur told me, Mario, we are bringing something from the backend. That information that you are bringing from the backend is, and the first statement is pending. Why? Because you don't know what the backend is telling you. Then you can use this one. Then this second then arrive for fulfill it, or in this case, rejected. You send in a request. That request is pending because you just send it. Then this one, ping, when I say ping is when your API or when you request arrive to the backend, that is called it a ping, then the backend responds you with something. And this response, enter here. Response. Enter here. Okay. If I, for example, if I just save it this, I run, I still have a promise. This promise has not been resolved. Why? And I will tell you why. Because this one that you have here, this one that you have here, has to be converted into JSON. That is something that you were doing last time. This one create another promise that pass into data, and this one you pass to data, you just say data, right? Okay, I would just in this case console log this data, console log this data that I have here. Okay, you go, you run, and here you have your data. This is what you are getting. Okay, the promise is created. This one that you see here. This promise can be fulfilled. This is fulfilled. Then the information what you bring in from the backend is called, in this case, raw information. I will just show you right now raw information that is arriving here. I can even show you this one before arriving to this data. Before arriving to this data, we can just see it here. Console.log, and I want you to see this information. This information is raw. Here you have it. This is the response. All this information is the real information that is coming from the backend. Let me just go and show you to here where you can see it better. Here is. This is the information that you are arriving from the backend. You can see it like what is the type of information, all the data that you send it and is bringing back from the backend. The response from the backend, as Amantur say, hey, you went to the backend, the backend checked everything and respond you with some information. But this one is raw. That means like you cannot work with this information. What we have to do is take all this data and transform it into, in this case, JSON format. Okay, fine. This JSON format that we are having here, this JSON format, I will just get it, passing it, and I pass it into JSON format. If I console log this one, I will have another promise. It sounds weird, but arrive it, and I have a second promise. This second promise is bringing me the array. Look, here you have it. Promised state, fulfill it. Here I have promised state, will come, arrive it in it, fulfill it. And this one is giving me the array of data that I can be using. This is when a promise is fulfilled. The first one, look, pending. The second one, fulfilled. And the result is the array that I am bringing it. Now, let me add one error here. And I will save it. And I will refresh it. Pending. And here we have it. If I open this one, say fulfill it. If I open the second one, is rejected. And those are the 3 states that you can have into a promise. A promise is considered an object that allows you to connect to the backend, but majority of the time exists another type of promise. But in this case, that's it. We use it when we are not secure what is going to happen after this request is sent. You send the request to the backend, but maybe you are sending a wrong request that is a not correct request, then the backend will respond you with one error. Maybe the backend is not working, maybe you don't have internet, maybe they can go a lot of things wrong. That is why we use it, in this case, something that is called catch. Catch, get the error, and I can say console, log, you have an error. And this one will avoid to have just that error, but it's not a big stuff that you are having here, right? You have an error and all the information is basically arriving. And those are the 3 states that we have into the promises. The most common promise that we know it is fetch. The majority of time, this information, let me just fix it in order to have it. Products, okay. Response, response, then we have here response.json, And this one I pass it to 10. Then I get the data. And here I can just console log the data. And all cool, right? I don't have any inconvenience. And this one is completely working. This is you can say it, an old way to get this data. Okay, so far, question with these three states of the promises.
No question.
Okay, cool. Then, as you told me, we already saw async away. Can someone explain me what do you understand about async away? When do we use it? What do we use it? Why we have to use this async away? Nur Sultan?
Yes.
Can you tell me what you know about async away? Why do we use it, or what is the reason?
Just another method to write with Zen. Like it doesn't create the. It makes the code readable. It basically the same as that with Zen, but it just with the weight is more readable. And away just waits for the line to finish and then goes next. That's all.
From the line to finish and then go. 90% I will tell you yes, but there is a little more over there. Not exactly the line to finish, because I can put away to any, that will say like I can add away to any line and it will wait for that. And that is not absolutely correct. Okay. Someone else?
It only works with asynchronous functions. Because the code itself is asynchronous.
Exactly. In this case, Joseph function in this case with asynchronous. Okay. Well, let's go. Let's rewrite this guy here. Let's create, in this case, a function, right? We create a function, and this function, let me just sing. A sing function, okay. Okay. We create a function that is calling an API, right? Calling an API. Call an API. This call to an API, this call to an API is just API is just a simple function. And what this is doing and is create a const that is data. This data, you say, for example, fetch, and that is creating some information. When we get it, and we just use the same information, right? This is the same data that we have. Then const, let's call it request, because you are, I think that is the way that you already know it. And here we have data, and the data in this case would be equals to request.json. And we have all the information here, console.log, and we have data. And I will call this API. What is going to be printed in this line when this console log happens? And why? If someone can help me with that. What is going to be into my screen right now? I will have an error, I will have whatever.
Yeah, well, you will have an error.
I will have an error. Okay. I will have like a promise maybe instead of an error.
Um, let's find out.
Maybe you will have similar data. I don't know. Just ideas.
You will have an
Okay.
error because this function says like it's gonna do everything line by line, and it will not wait response from the API. So it will try to
Mhm.
do it right away. So that's why we all got error. Yep.
Okay, let me just remove this one. And let me just, okay. Still?
No, now we will
No.
not.
Yes, it will still the error.
Oh,
This is back?
No, actually, yes, it will, because we should let system know that it's going to be asynchronous function, right? First.
No.
No.
Well, it just empty, I think.
Yeah, no, because in this case, this one gets fulfilled. This one gets fulfilled. What give it to you is a response that is a promise, as you can see here. This one is happening here. This is the promise that we can see it, that this is arriving. But cons, when I say data, and I say request.json, this is the one that is giving me problem, but it's giving me problem from one reason, because a promise doesn't have the property JSON. The property doesn't exist. Okay, then we just say it, okay, we need a sync. We say await. Okay, that is the thing. Await is not waiting for the line to finish. Is waiting for the response to be resolved or rejected. That is the small difference between one and another one. Because Nursultan told me, is expecting for the line to finish. Yes, but I say it 95%. Because actually the what is waiting is for the response to be fulfilled, not for the line. The line is read, because even though without this one, without this line, and without this one, I can do this one. And this is absolutely correct, because the API, if you see it, is reading it, finish. You have a promise. What is not resolved, or what didn't finish, is the promise didn't resolve. That is the difference between waiting for the line to be completed. The line was read, the fetch was in this case triggered, and you have a response here, but it's not resolved because the promise hasn't been fulfilled or rejected. That is the thing. It's not waiting for the line to finish. It's waiting for the promise to be resolved. Then, if we go here, async, now we say await. We say await, and we go with the data. We go with the data here. Now, what do we do it? What do we have here? JSON is also a promise. Look, here you have it. JSON is also a promise. Then we also have to wait for JSON to transform all the data that we have it. If we don't have this JSON here, we have the raw information from the backend. Look, here you have the response with all the information, with the buffer array and everything. You cannot work with these things. It's a lot of data. This is what the backend give it to you. This is the real response that the backend. But as a front-end developers, we cannot do much. We pass it into JSON. But what happened? JSON has to take all this data and transform it into an object that we can use it. And that one, it will take some time. And because it's a promise, we use await that It's not awaiting for the line to finish. It's awaiting for the response to be resolved. And now we have the both, how can I say it? The both type of data that we have it, that they are just the same information, right? This one is called syntactic sugar. This thing that you see here is absolutely the same thing that we have here, but here we have something. We always need to use try, right? If I'm not mistaken, it will be like this, try, and we will have in this case catch. Catch will get an error, and he will say console.log. I have an error. I am an error from the API or something like that, right? We create an error here. We save it, we run it, and I am an error from the API. This one is this information. And we have this try on cache. Try to do this one. If doesn't work, do this one. It's like the second case. This catch is, in this case, the one that I was doing here, okay? The catch. And there is no more. Try to get used to, please. Try to get used to. I will ask you again, please, to get the catch. The majority of the time I see developer doing this part like this. This one is not good because you are not you are not managing your error, right? Then try to manage your error all the time, the best way as you can. Just bad things happen from time to time, and that will be everything about in this case. Async await, try, and the other something. Okay, I sent you one article that is in this case in Mozilla. I will suggest you to read it about async functions in order for you to have more information about it. Right? And with this, we finish in this case the promises async await part. That it was part of the quiz, but I wanted to go for a small review before everything. Any question before continuing?
No.
No, okay. No question because everything is like a black, or no question because it makes a little bit sense. Just three things I want you to keep it in your mind. That yes, Joanna?
No, I wanted to say no question, but because everything it makes more sense.
Okay, cool. Yes, and then just this thing. A promise is something that is going to happen in the future. They have three states. When it was created, it is pending, rejected, or in this case, fulfilled. Nothing more. And async await is just a different way to write in this moment the function. Okay? That is absolutely everything. If we are okay, then let's continue with other stuff. I want this second part of the class, okay? We will be using NT squared, big O. Okay. Okay, 1 second. I still have some fluent. I have to be. Okay, let's go. Today class is also called the big O notation. First thing, I want to take this part with a little bit of salt and don't take it that seriously if doesn't make sense in the first class. Basically, the majority of class, we will do it like this. Beacon notation or solving problem or solving algorithm, data structure and algorithm, doesn't have to do anything with clean code, okay? Two things. Clean code is what we build at work, like, and solving problems is another part of the computer science. Big O notation is the way that we use it in order to measure basically measure the speed or the in this case how effective is the code that we are creating, right? You can create code that is fast and you can create code that is clear. There are two concepts that they don't have to be mixed. Clean code doesn't have to be fast code, and fast code doesn't have to, in general, to be clean code. If both are together, that would be great, but that is something and that we will have it over here. First thing, we will be checking some math. Nothing to pay too much attention, but a basic algebra will be useful. For example, understanding that sometimes I will say it x or right, like a function, right? Function notation, or in this case, scientific notation can be used. These are the objectives of the class. One is motivate the need or something, or why do we need this stuff called big O notation? What describe big O notation? I mean, it's like a speed, right? You say, why do we need to know how to measure the speed? The other one is how we can simplify it. And these are the two things that I want for this class to be 60% clear. What is time complexity and what is, in this case, space complexity. And evaluating the time complexity and the speed complexity, or the space and time complexity of different algorithms using big O notation. And when I am talking about algorithm, let's just say like an algorithm is a bunch of the steps in order to fulfill something. I have a task, I create a lot, the different steps that I needed to resolve this problem, right? If I have to sum two numbers, I will create an algorithm that it will take number one, number two, add it, and gives me a response. And that is an algorithm. Very simple, but it is. Okay. And what is an algorithm? Okay. I will try with that here. The idea about big O notation, or in this case, data structure algorithm, is sometimes we are creating code, but this code can be a slow code, or can be, in this case, a fast code. And big O allow us to see faster where we can find these bottlenecks, where our code is slower. That is the main thing that we have it. One thing, as I was telling you before, let's determine which one is the best. And this the best, we have a lot of commenting what is the best and what is not. Why? Because sometimes not the fastest code is the best code, and not the cleaner code is the faster code, right? I just want to be very clear in that part. Clean code and optimal code they are not usually the same. They are not usually the same. Okay, look, here we have it. Write a function, and usually we have here, write a function that accepts a string and input as an input and return you the reverse copy. You can do it great, you can do it good, you can do it okay, you can do it or you can do it awful. It's just about different. This is not a measure that we have it here. Who cares? Okay, for example, you are in an interview and I told you, write me a function that accepted the string as an input and return me a reverse copy. You can do a different option, but who cares about the way that you are doing it? Okay. First one is useful for discussing the trade-off from different approaches. When we are creating one function, we are usually discussing, okay, what we will do. Okay, this function will take in this case, the string. Then after that, I will just create a new variable with let that it will be an empty string. Then that empty string, I will create a for loop, and that for loop will go for every single string, and I will just add in from the end to the beginning, and I will take it the last letter, and I will put it the last letter first, the other one, the other one, the other one, the other. Okay, and we finish. It's not that complex algorithm that we have it over there, and I am just giving a solution. Efficient, yes. Clean, yes. And we go over here. But that is why this is important. I see it like this, and this is my personal opinion for what I'm going to say. I think that structuring algorithms or knowing about Peacock notation is important for like a weightlifting. It allows you to train your mind and for interviews. It's not good for writing code in production. In production, this is not that important. Then you have to understand there are excellent lead coder or solving problems and are excellent developers. They are not usually the same. Let's say that we had to create a function that calculate the sum of all the numbers, from 1 to n. From 1 to n. Including the number n. And we have it here. We have a function add to n, and it's saying it's similar, right? Let total equal 0 for this total, and is arriving in this case to this total. We say it, right? Say console.log, and I will just, let me just add here 10,000. Then 1, 2, 3, 4, 10,000 here. Oh, I'm sorry. Add up to 10,000, right? 10,000. And I run that one. And here is giving me the time. Let me just go over 100,000. I save it. Here you can see the time, 200 milliseconds. There is not much different. Let me add one more. That is not going to a big number. Let me add one more here. Let's go. Okay. And I will add one more. Okay. What is happening when I am adding, in this case, 1 every time that I increase in the number, every time that I increase in this number, what is happening with the response? Here is the response, here is the response, here is the response, here is the response, and here is the response. That is what we're having here. Here is the response. What is happening every time that I am increasing the number that I am evaluating?
Every time you are plussing 1. You're adding 1, yeah.
Yeah, I am adding 1, but what is happening with the response?
Increasing the time, right?
Increasing the time. Yes, that is what is happening. That is what I wanted you to note. It's increasing the time. That means it's increasing the time. For example, here it's increasing the time. Look here, it took you this one 24 seconds to do this. And this one, my friend, is already a good time, right? Then that means like this function depends on the number, right? For example, if I am passing the number 10, and then passing the number 10 in this case, passing the number 10, let me just clean it here. Look, boom, super fast. I am passing now this big number, and I run it. Okay, it's taking its time, it's waiting, it's evaluating the function, it's running, and after some time, imagine if you have to be waiting for this kind of response. I doubt it that you will have, in this case, to create this kind of response. Then that you have your response after 24 seconds. After 24 seconds. Now let's continue with the other part that we have. Now we have this function. I want you to be very careful when you are using a mathematical expression. But in order to add the numbers from one number till the end of another number, exists one mathematical formula. This mathematical formula say like the sum of all the numbers are equivalent at multiplying the number, multiplying it for its number plus 1 divided between 2. It's just like that. It's a mathematical formula. I didn't invent it. It was some very smart guy who did it, not me. And here add two numbers, and I will get the number 2, just to see it. Now, I will just go over here, and I will just say 2. Here, I wanted to write the number 2. And let me just remove it here. And I will just have it with one number less, because this formula tend to have errors when the number is too big. And that is normal. We have a safe number here, but no. Okay, I will just run it. There you have it over here. Let me just not call this one, and I will call just the second function. And there you have. It's the same number. It's the same number. Look, I will run this function. I think it was with 1 extra 0. Continue working, and it will take 24 seconds, right? We know that it will take 24 seconds. I will add this function, and in order to not to lie to me, I would say 2. Is the same one. And there you have it. It's just telling me that it's a very big number that I am having here. It's using, in this case, what is called scientific notation. It's like a 5 elevate to the 25 power of the 25. Which one is faster? This one is absolutely faster than the other one. Then that is the difference between an algorithm and another one. Which one is cleaner? Which one do you think is cleaner in this case? What you are doing over there? Which one is easier to read? What do you think?
Second one.
First one.
Okay, you are very smart because for me it's very difficult to read it.
Because it's just the limit of the sum.
But it's not, yes, but this is the limit of the sum. Okay, but if you give it to another developer who arrive it, it's very difficult to communicate. One is a smart code. When you are writing a smart code, try to avoid it. When we are talking about production, if this is in this case in an interview, please doing it. You are showing that you are a very, very smart person. But for me, it's difficult to understand this one if I just see it, right?
You can add
And
the
plus
description.
but if you are needing a comment, I am just saying like that. This is the fastest code, but it's more difficult to understand it without the comment and without to have this knowledge about limits, right? Because it's not something that everybody knows is by on the top of their head. There are some people, yes, but common humans like me, maybe I don't remember this on the top of my head. But if I see this one, they are taking the number. This is the total. You are iterating and summing and everything. This is readable code. This is optimal code. This optimal code is faster and it's good for interviews and it's good for everything. We will be trying to use mostly this one, but this one is, in this case, more readable. Both are correct. I am just saying in this case, don't get confused between readable and optimal. And then we go.
Yeah.
Yes.
First code, is it doing the same thing? Is it going through all the through
No,
the
no,
array?
no.
No, just
no.
calculating stuff.
It just
How-
calculated.
How the first this formula is working? Is it dividing to two?
It's called in this case as Nur Sultan said, it is calculating the limit between the first number and the last number exists.
Okay,
Okay.
it's using different way, not going through all the array,
It's using math.
the math and calculating so everything in between then.
Exactly. And this is just math. Okay, I will not enter into the topic about math because I think like Nur Sultan can explain it better than me this
That's
part.
a really smart way.
Yes, and this is the calculation, right? But we can just look for the information if it exists. Okay, let's continue with this. Let's not take it. Just I wanted to show you that one is slow, one is fast. In this case that we have. Okay, Nur Sultan passes the information here. Okay. This is the mathematical production of the sum of n plus n divided between 2. Okay, then there it is. Please watch it, and I think it's very interesting how that thing works. I think like there is some limits that this thing work properly. I don't know the one, but which one is better? And here we enter into the debate, right? And you are saying the first one is more readable, the second one is faster, and which one I will take? Depend. And depend on what? Because if they have a small limit, imagine if I just will calculate it till 10,000, even to 1 million, you will not even see much difference between one and another one. But when this number tends to arrive to the infinite, then is when the problematic start. Why? Because in the small function, this doesn't have any inconvenience. It's just adding, and creating a many copies, right? Here, for example, we are just adding. I add 1, I add 2. If I go into the number 10,000, I will loop 10,000 times. 10,000. If I am looping 1 million, I will be looping. If I have 1 million, I will loop it 1 million times. If I have 10 million, I will do it 10 million times. And then if I pass here 10 million, this will happen one time. It's just a mathematical operation. It's just a simple arithmetical operation. It will take 1 million plus multiply for 1 million plus 1, and then it will divide it between 2. And that's it. And all the time will be the same information. But the other one is increasing within the time. And then we give it here. Okay. And he's faster. Absolutely. This guy is faster. Less memory intensive. Absolutely. This is less memory intensive because if you see it, I am not even creating any memory. Here, I am creating one variable. When we are talking about memory, remember it's just a new variable that you are creating. That variable that you are creating is opening a space in your computer that you are saving information. Remember that in your hard disk, you have a limited space of memory that you can use it. After some limited space of memory, in this case, you can. I am not sure that sometimes you have to enter into one place that everything got frozen, and you are not able to do anything. Maybe your, in this case, the memory of your RAM finished, right? Like it was consumed completely. Maybe it was an error like this that we have it. And which one is more readable? Okay. Exception is that you are very well literate about mathematics. This one will be always easier to read. And the best comment of a code is a code that doesn't need a comment, right? Sometimes it's necessary. In this case, I also will go with Nur Sultan and say this is the best option. And I will add some comments here and why I'm using it. But if only in the case if I know that I will be using more than, I don't know, 10 millions or something like that. Less than that, no. Okay, and which one is more readable? Okay, which is more readable? Okay, this is not that fast. And here we go with the first, let me finish this part and then we will continue with the other one. We have one problem with time. How we meet time. For example, let's say like I have one computer that is I don't know if you know Pentium 3, right? Pentium 3 computer. I remember that it was like something like this. I used to have it. It was in 2004. They were so cool. You don't have idea what is this one, maybe. But I have this computer. And for example, in this case, Kai has this computer. He has this computer. He has this computer here, right? So cool, M2 and something, something, and you have this one, for example, right? You have this beautiful computer and everything. If I have to multiply something, if I have an operation, in which computer do you think it will be faster? In my computer here or in Kai computer here?
With M2 on ARM.
Because you have more power on in this case the computation, right? It sounds very stupid, but I just want to make a point. Why you're like, why Mario? Absolutely, I know that M2 will be faster, yes. But the one I tell you is that is why we don't use milliseconds to calculate how much time or how fast is an algorithm, because an algorithm will change depending on the computer that you are using. For example, if you have an enormous computer that is doing a lot of calculation per second, then you will not feel this slowly or this slow part of the system or not. Then that is why when we are talking about time, we use about something that is called time complexity. And this is measured in something that is called O. Why? Because O, let's think like that this is operation. Okay. Operation. How many operations you can create? Okay. How many operations you can create? How many operations we need, for example, here, and this up to how many operations we are doing? Do we say operation 1,000 or 1 million? Operations, operation 10. Okay, operation, this number. Okay, that means that the operation can change. Because the operation can change, the operation depends on the number, and this number, what represent this number? This number represent how many times this for loop is going to work, right? 1 million for loops. Then 10 times this for loop. 1 million times this for loop. In computer science, we say this is because of n. Why? This means n represent the number of operations. And we just say, you know what? This algorithm that you have here, this up to will be big O of the number passed as an argument. That means if I pass 1 million, this will be 1 million. And think about if you are the owner of Facebook and you have one function that it's is repeating. If you have to review this for 10 million people, how many times this for loop is going to run? 10 millions, right? Or 10 billions of people. Now, this another one. We have operation. How many operation will be happening here if I pass the number, this number, 1? How many operation will be if in this one number is just the number 100? This one will be 1. Why? Because all the operation that they are just multiply, division, or everything that you have, everything that is algebra, is just get resolved immediately. That means one operation. This one that you are seeing here is called constant time. constant time. Mhm. Okay. The big O notation, we can just go here, big O notation. I think so, okay. Big O notation, we will just arrive at here. Here, we have it here. This is, in this case, that is called constant time. A constant time means that this function will just create one operation, just that. Any mathematical operation, it will be just one time. If I pass 100,000 millions or billions or trillions or any number that you wanted, it will just take one operation. How much time it will take? That is something that we don't know it, but we have it over here. That is time. The time is constant. You will see it here. Then we have the other one. This time depends of the number that you are adding. Ah, okay. Then we call this one big O of n is also called linear time. Linear time. That means like if I pass 1 million, it will take 1 million operation. If I pass 10, it will just do 10 operations. Everything will depend on the amount of the operation that you are, in this case, performing into the algorithm. Now, let's see a couple of things. This big O notation allow you to understand or to see like in more detail which algorithm is faster. Okay, if this take one time and this take n times, that means like it doesn't matter. It doesn't matter which number I pass here, it will just be one operation time. One operation time. And this one doesn't matter. This one is very important to know the limit. If the limit is too big, then the algorithm will be too slow because it will depend into the humans that we are having here. Think about it. Think about it. This is simple stuff. This one is like when you have a line into the, for example, into the supermarket that you're going to pay, and the cashier is just doing one by one, right? It's doing one by one. And there are 10 people in front of you, you have to wait 10 times for be attended. And that is what is happening here. But if, for example, if you have enough self-serve cashiers where you just scan your thing and you pay yourself, let's imagine in the perfect world that there are enough, always enough this empty cashier, then you will take it the time that you scan and then you pay. That means like a just operation. You don't have to wait for any other operation to be performed before your operation. And this is one thing, and it's called time complexity. And also, time complexity is measured into operation to be performed and not into time. The main reason is because if we measure it with time, we will have the inconvenience that you have a very fast computer and I have a very slow computer, and I will tell you it's very slow and you will tell me no, it's very fast, it's working well. It's because the difference of hardware that we have over here. And that is the first part. That is why, and we are using big O notation because just is easier. And remember that computer science is also part of the science. Then we also try to use scientific notation. In this case, and big O notation is one of the ways that we tend or try to measure, in this case, what we have it. And here we have it, linear. Linear, that means increase it in portion of n. If n doubles, the time performed doubles. And now we have it. Big over 1, we have remains constant regardless of the size of the data. Doesn't matter what I am passing it, they will constant, doesn't matter what is happening. In this case, it would perform it. The majority of time, every time that you have a for loop, just thinking, oh, this is linear. And this is a very easy way to understand. Okay, this is linear. If I have a for loop, this is a linear function. That means like if I am passing 1 million of files here or 1 million of everything here, it will do it 1 millionth of time. That's it. And that allowing me to just to read the code faster because of n, because this number represent the times that the for loop is going to run. Questions so far? I am trying to go as okay. Okay. If there are no questions, let me just see. Sarina, that makes sense what we are talking right now about time complexity, why we don't use seconds or in this?
In general, yes, but I have to go over it one more time because it's a little bit complicated for me. I will try to understand.
Okay. Kai?
Yeah, it makes sense to me.
Elsada? Vector? Makes sense so far?
Yeah,
Mhm.
Mario. Yes.
Oh, okay. And the other one, if for someone doesn't make sense, this part or anything, just keep it, just tell me. We will be using it all the time, and I will try to go slow in this one, right? After continue with
So
the
yeah, excuse Mario, can you go back to that? So for loop.
yes, yeah.
You said then so depend. This is a big O of n, right?
Yes.
So and you also said that it make so it's allowed to up to some point, but we can't. So if it takes a long time, it doesn't make sense to use this code, right? So we have to change this code to another one to make it faster. In case it works slow, if you have millions of so information to loop through, it's gonna be slow. So yeah, how we know that
Oh,
when
that is a
when we need to change this code or optimize this code to different one.
when you there are two things. When you are writing the code, you may infer what you are expecting, right? For example, if I know that I have just 3,000 customers, then I say I have 3,000 3,000 customers. It will depend on the requirement. And when you will know when to change it, when your customers start complaining about the speed of your software. That is the main, there are two things. If you are talking to me about an interview, then you have to see most of the time when you see something like a for loop or a while or things like that, you have to think yourself, there is a way that I can optimize this code, or do I need to go for all the elements? That will be the main question, because sometimes it's not about that. If it will take me 10 days to calculate everything, and that is the way that has to be, then you don't have option. if you have to iterate for every element, right? You have to pass for every element. But
So yeah, yep. For example, yeah, so if I need to get the username, I don't need to loop through the array. I just need to use object, right? And to get that exact so username, it's not going to be then O of n notation. It's going to be O of 1 notation then if I use objects.
that is why it exists like a data structure that we will see how we can optimize some data in order to perform that. But you are just talking about searching. Then searching will be another topic that we can do it. Into the data structure exists linear data structure and exists complex data structure. I will try to go over those data
Okay.
structure through the course. Through the course, I will go it because, for example, Google is not using for example, Facebook is not using an array to collect the data of all the user, right? They use something more complex in order to save the data. They look about relationship between what we have. That is something different, but in general, right now we are going with the linears just to see it. Okay, if I see this for loop, for example, if I need to optimize this code, I cannot optimize this one. This is impossible to optimize because it's just pick over one, just as initializing the variable. This is just returning. I cannot optimize that. Then if I have to optimize, I will say, okay, a for loop. A for loop is big O n. Maybe here I can find a place to optimize my code. And this is also one part that big O notation they help to you. At least to say big O of 1, big O of n, big O of 1, I can optimize maybe this part. And when you have a big code, it allows you to scan faster and to find places where this code could be or not optimized. But I am saying it will depend on the case that we have. And that is what we are going over here, right? Different machine, different time, different machine can give you different times, another thing. The measurement can be not precise enough. Then we cannot use seconds. Let's count the numbers of operation. That they were saying we are using operations. How many operations this computer perform? And we should say here, how many? One multiplication, one addition, one division. 3 simple operations. And this one we have n additions, n assignment, n addition, one addition, n comparison, wherever. I mean, that is completely impossible to know. You just say 5 times n operation, right? That it was saying. How many times I will create this one? N times. How much this I will be changing? N times. How many times it will be happening? N times. That is already a headache. Then instead of doing that one, you say, okay, this is big O of n. And that's it. I mean, this for loop will happen n times. This one will happen n of 1. And this one will happen big O of 1. Sorry, here was big O of 1. And in order to know the algorithm, we just look for the biggest one. Okay, this is 1, this is n is the biggest one. And then you just say, okay, this is big O of n. Big O of n. It's just, we are never looking for in this case, perfection. We are not looking for perfection when we are talking about computer science. In another science, we are perfectionists, but here we just say, okay, this is the worst case. In the worst case, this is going to happen. This is the worst case. But there is the best case. There is the best case. And which one is the best case? The best case is never taken in consideration because imagine if I had to pass the number 1. This is the best case, right? How many this will happen? It will happen just one time. Then it can be just because of 1. The best case is that it's just one element. The worst case is, in this case, that we have it 3 trillions or 200 millions of numbers over there running. Then this is called upper bound, upper bound, upper bound. I hope it is written like that. And this one is called lower bound. Like in one algorithm can be, okay, the minimum will be 1, the maximum can be infinite. Then you always have. But in order to, if Kai arrive at Mario, how fast will be this system? Okay, look, if it's just one user, it will be very fast. But if you already have 10,000 users, this thing it will go going slow. Why? Because you have to evaluate everybody over here. Okay, I said, sorry, I got excited here. Then that is why it's important big O notation, because you can infer what is going to happen in the future. Okay, let's take 10 minutes break. If we don't have question before going to break. Okay, cool. Then let's take 10 minutes timer. Okay, cool. That's cool. I added one timer. I didn't even know that that thing existed. Okay, let's continue here. Counting is hard, and that is why we never think about a specific number, right? We are all the time thinking like in general. We don't know how fast or how slow will be one. Then we have the upper bound or the lower bound. In this case, in another place, we will see it the best case and the worst case. In the worst case, it will be a very big number. In the best case, it will be just one number over there. Just use it, as I said, with a little bit of salt. Not all the time. And this is for solving exercise, okay? If n doubles, the number of operation will also be double. It's just like that, as simple of that. Okay? Big O, this is what we're talking, is a very, is looking like a very fancy word, like a big O notation, or like a constant notation, or linear, not big O of linear, big O of n and everything. But being honest, it's just a way that we say, "Hey, look, this one will have one operation, they will have n operation, they will have n to square operation and things like that. It's just telling someone, look, this will be fast or it will be slow. I mean, depending on the people that we have together. Just keep it a thing. And as I said, we don't care about the details. You just go into the algorithm, and see which one is the worst. Okay, this one can be n. Why? Because this is the biggest number that I have. N. Okay. By casualty here was n, but this can be any number. And we have become n. By n, we just refer to number x. That's it. We have it over there. It's just that we have it. We say that an algorithm is big O, or the time of the function that is in this case, that the constant times of the function are the same increasing. Fn could be linear, could be quadratic, I will show you one example about quadratic right now, and could be in this case constant that we saw it, or could be very different. Let me just go over this one, and I will just wanted to show you here in general. This one that you are having here, this is big O 1 or constant time. These are basically operation, mathematical operation. Big O n, log of n, there are some algorithm that is someone had let me just see, like that is something that is called binary search, that in one searching algorithm that is very good. That is big O log of n. Then we have big O of n. Usually big O of n is anything that has to be related with arrays or with objects. The majority of time they are like that. Big O of n log of n, this one tends to be searchings when you are searching something into something. Sorting, sorry. This is the majority of time that is sorting. When you have all the pieces around, you have sorting. And when you have to put things in order, the majority of time here. And we will saw all this type of algorithm. Then we have these squares. There is one specific, like, or in this case, that in this case is quadratic, mostly bubble sort that we will see it right now. This is cubic. I have never had a cubic. Then we have this that is exponential. This exponential and this one that is called also factorial. You don't have to remember those things. With the time we will go. But this one, are you see it like a Mario? This sounds very stupid. But you know, this kind that is exponential or is factorial, they are usually used in things like, for example, when you are using maps. When you are using map, and let's say like I want to find this one, and I get the direction. This line that you are seeing here, it was created basically with one algorithm that it will be maybe very possible will be a quadratic or even exponential. Why? Because the artificial intelligence that we are just usually doing it is just doing like this. Look, is like, for example, here. Can you see? This is where I live. And where I live, there are different options, right? There are different options. And that option, they have to be checked to arrive to one place. And then, for example, here, I have a, let me see, just I have different options. I have this option here, I have this option here, I have this option here, and I have this option here. When I arrive here, I have this option here, this option here, and this option here. And every time that we are arriving to one place, we have more options, right? Then that means this is exponential. That every time that we arrive to one place, the option multiply, and we have to look for those options. The majority of time when we are talking about maps or finding information like a maze or things like that, we are using basically factorial exposure because you don't know how many routes you have it. And in these cases is when we use this kind of algorithm. And I will try to basically at the end of the course, we will create something like a maze solver in order to do it and to prove how this artificial intelligence is working. But actually, you are just looking for the different rows, like this arrive you to the end, this doesn't let you to any places. Don't, as I said, let's just go over here. I will just delete this stuff and let's close it and continue. These are the different big-of notation that we have. As a front-end developers, I will tell you that the most important will be for you this one, this first four. The first four is linear, then is logarithmical, then in this case is linear, and the other one in this case is n log of n. This is sort. This in this case will be arrays. This one we will have basically sortings will be in this area. And these are simple operations that we have. Remember, today I am just giving you basically an introduction to this thing. I will go over every of this one with examples in order you to see it into consideration. And we are saying like, these are so good, these are medium, this is a bad algorithm, but these are relatives in this case, depending on what we have it. These are the three that we will be using the most: linear, quadratic, and constant. Here we have an big of n, linear. We have constant, and we have constants. And something very different depending what we have it. In this case, we have three operations, big over 1 or constant time. We have n number operation, then we say n to 10, then we call it linear time. That is basically what we have it. I would like, please, let's copy this one. I will just copy this one over here. Would you mind to help me to identify the big notation, big O notation of these elements that we have here? For example, this one, Kai, would you mind to help me here? What do you think is the big O notation of that specific operation?
You mean the console log or for loop?
The console, just the console, just this one, just the 39,
Just
just
console
this.
log is gonna be O of 1.
Exactly, because it's just a simple console log, right? That we have it. Sarina, would you mind to help me with this one? What do you think is the, in this case, the big O notation of this for loop?
I'm not really sure about that. I can
And
help
it-
you,
No, no,
unfortunately.
no, you can tell me like, I think it's this because of this. That's it. Just give yourself a chance.
Because of one operation, maybe it's one.
It makes sense.
Oh.
It's very possible.
Oh,
Yeah, tell me.
got it. Oh, we
Tell
have,
me.
I think it's LON,
Exactly. Why?
because this operation, this loop where n times. and it's-
Exactly. Perfect. That is perfect. X time. You don't know how many times it will run, right? It will run n times. That is perfect. Oh, look, you knew it. And just a little bit more. Every for loop, most of the time it would n times here that we have it. Okay, then we have another console log. I will not ask because I feel like we have it clear in this case that is because on n. And this one is inverse. Don't let this kind of thing fool you. And for example, say like, then it's one, right? No, it will always the for loops. Doesn't matter, even if you go to the half of the array or whatever, they will be always big O n, and then we have big of one here that we have it over there. And at the very end, I would like, in this case, if you don't mind, Isara, would you like to help me here if you have time? Which will be the big O, in this case, time, or the full function? Or Ian. Okay, Isara. Okay, here.
I'm not sure, honestly.
Give it a try. Just a guess. Or Ian, if you don't mind to help me.
I will just guess Pico 1.
Well, it's very possible. Yes and no. I will tell you why yes and why not. There are, as I remember, I told you that exists two cases: the best case, and the worst case. Okay, the worst case. In the best case, it's because of one. Yes, because maybe I will just pass the number one here, right? Then every n will be one. But which is the worst case in this case? The worst case a scenario that that we have here. For example, I don't know. Aisa, if you want to help me here, or Joanna, or Delzada, anyone?
I would
Yeah.
say big O N in this case.
Uh-huh. Okay, that is absolutely cool. Yes, and why?
Because of the for loops.
Exactly, exactly. And something that sometimes people get confused. Oh, then if we have two for loops, maybe this isn't square, right? But no, this is just big O N. It doesn't matter how many times, it will just be performed. We can say it's big O of two ends, right? Because we have here this one for loop and two for loops. But in computer science, we just remove that two because it's not useful. And we just say it's big O of n times, n operation we'll have it over here. And that's it. There is no more science into time complexity for now, right? Right now, I have showed you just linear, in this case, linear, and in this case, constant. Let's keep it like this for now. We will introduce more later, but for now, we have here pico of n, pico of n, and okay, then we have pico of n. Those are the biggest one that we have. Okay, this one will be funnier. It will be cool. I will give you this one. I will send it to you in the chat. Please read the function, and investigate, try to investigate right now. Take 1 minute and in private, send me which one do you think here is the big O that you have it right now. I haven't shown you this one, but I just would like you to try to figure it out. You can see it and just text me in this case. I think it's this one. How many times this is going to run? Thank you, Amantu. Selena, cool. I am interesting. Makes sense. Okay. 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 This is something that oh yeah, correct. Yep. Yep. It's very interesting. Aisada, why it's like this? Would you mind to explain me? Because it's correct.
It's
But
not.
would you mind to?
It's
It's
the
correct. It's
yes.
correct. But why?
Because we have one N for the I,
Mm-hmm.
for loop for the I,
Uh-huh. And
and the second one comes from the second for loop for the J.
yes.
So N. So like big O for N, and we multiply it for the second one.
Yes, it's multiplied. It's not added, right? That is the difference between. Is absolutely, you are completely correct, because I received this answer too. Look the difference between this one means multiplication. This means n to the square. Basically, this one will represent it in something like this. Let me just go over here. I don't have this symbol in my computer. Okay. But this one, it will be like this. N to the square, n to the square. How you are doing it is absolutely correct. This one means 2 times the n that we are having here. Ah, thank you, guys. Yes, exactly. That is the symbol that I wanted to use it. This one. What have it here? This for loop is big O of n. As I said, this will run n times, but inside will also run n times. That means if I pass the number 2 here, look what is happening. I will just pass the number 2. This one will run 2 times. Ah, okay, 2 times. Will run the first time. Now inside will also run 2 times. 1, 2. Then I will run the second time. 3, 4. It ran 4 times. It didn't run 2 times. It was running 4 times. This for loop that I have here, 4 times. I will pass the 3 times. I will pass the number 3. Here, number 3, 1, 2, 3. I will pass it again. The second iteration of the first loop, 1, 2, 3, 6. The third iteration of the first loop, 6, 7, 9. That is 9 times. How we know that one operation is quadratic? Just look this. Loop inside loop. And that will completely be, as Joanna told me, this is called a quadratic. It's a quadratic operation. And this thing, what you are doing here is a pity that, for example, that someone left, but this one is permutations. Most of the time when you are creating combination of permutation, combination, in this case, you will do it. For example, here, I will just say it, print the pairs, and I will just go here, print the pairs, and I will see 3. Look. And it will print me 6 numbers. To console, print all pairs. I will stop it, and this thing is gaining very slow. And I will just print the number. Look, 0 with 0, 0. This is going here. 0 with 0, 0 with 1, 0 with 2, 1 with 0, 1 with 1, 1 with 2, 2 with 0. So it's just printing me the pairs in this case. And this is called permutation. For example, if you need to find, usually this one you are using, okay, find me something between something and something, and you have to find a combination. Imagine that you have to make a lot of colors. You can use something like that. Now, let's do it even crazier. And then I will call this one X, 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 and here I will say X. What do you think is the peak of notation of this one? Someone that can help me here? It's doing basically the same. And here we have it. That will be, thank you, Serena. It is completely correct. And in this case, you will have a big of notation that it will be big of, or basically that will be cube, right? Big of cube, or usually we just call it in this case quadratic or exponential. It will exponent depending of the information that we are passing. It's very unlikely that you will have this kind of operation. It's very unlikely, but I wanted you to show you that exists. This case will be an exponential function. We have it here, big O of n, and inside we have a big O of n, n's operation inside n operation, n multiplied by n to the square, and here we have it, this information. Constant, that is what we were doing, determining the complexity. We were just determining the complexity of everything, not a big thing. The rules are simple that we need to know. The constant don't matter. Big O of 2, if we have to simplify this one, will be big O of n. Big O of 500. Can we simplify this big O of 500? This will be big O of 1. It doesn't matter if we have 500 operation, if every operation is just 1, it will be just 1. Big O of 13 to the square. What will be the result? And in this case, we will have big O of the square. The constant never matter. We are just having it here. Thank you so much, Serena, for sending me the answer. I appreciate it. Okay. A smaller 10 don't matter. N plus 10 will be always n. They don't matter. The 10 don't matter. 1000 n plus 500 will be just big O of n. Everything that is giving you nodes, we just remove it. And we have this big operation. What do you think is going to be the big O notation of this? O to the n squared plus 5n plus 8. I will appreciate if someone can help me with that.
I think it's gonna be just n in the square.
Exactly. Perfect. It will be just that. Because everything else doesn't matter. You always just go and see which one is the biggest one operation that you have. The biggest operation is this. And when you determine which one is the biggest operation, every other operation could be irrelevant. When we analyze the big operation, sometimes get complicated. Just look for the biggest n that you will have it. Always look for, if they are nested loops, they will always be to the square or to the cube that we have it. This rule won't always work, but right now I wanted to keep it like this in order to see it. With the time, we will refine the way that we are using it, but in general, they are just like this. Just a reminder, arithmetical operations are constant. Which are the arithmetical operations? As at the beginning, right? Multiplication, sum, division, and everything. Everything is this. If you see operation, this is big O1, the majority of time. Then variable assignment is constant time too. If when we are assigning a variable, it's also constant time. There is nothing more. You create a new variable, constant time. Accessing an element into an array is also constant time. Like for example, let's say like you have an array, cons array equals, and you have 1, 2, 3, 4. If you just want to say cons you use array 1. This is also constant time. Accessing to an element into an array is constant time. The object, as you may imagine, is also constant time. A for loop will be also, it will not be constant time, it will be linear time, because it will depend on how long it is. How many elements do you have in this operation? And here we have it. We have this function, log at least 5, that will be n, and we have this operation. If someone wants to give it a shot and tell me which is the, in this case, the big O notation of this function. And why? Kai, do you want to give it a shot?
I can try, yeah, because we have this for loop plus a mathematical this I don't know formula which searching for the maximum number, and you said the sorting or searching is
Oh, no. Max is not searching, it's just if. Which one is bigger? It's just an operation. This one is also because the operation itself is because of what?
Yeah, then maybe big O notation of n.
Big O notation on n.
Or maybe bigger.
Yes. Okay. Let me just.
Power of, so maybe n power of 2. So yeah, quadratic.
No.
No, okay.
No. You were right at the beginning, but now I wanted to use this one. And which is the big O notation on this one? This one, look for the minimum number. Which is the maximum time or this function is going to run?
Maximum time.
How many times is the maximum that is going to run? And if someone wants to help Kai, feel free to help him.
That's, what is it, 5?
It's 5. That is the maximum number. Then, which one is the big O notation of this one?
It's the same, right? Big O n.
No, this is big O n, and you are right. It's big O n. Now, which is the maximum time that this for loop is going to run? N, right? Which is what is the maximum time of this function going to run? Look, this is looking for the minimum. 5. And what we said when we have 5 here?
It was n. Oh, 1.
Oh, 1. It will be constant time. Perfect. Yes. Because remember,
Why it's for
this
1 and the second time?
Okay. Let's see. What you are saying here. Math get the minimum.
Oh, okay. Yeah, I got it. So it's just searching for 5, not for n time. Yeah, okay. Got it.
But if I pass here 3, it will be just 3 times. If I pass 2, it will be 2 times. If I pass 1 million, it will be 5. If I pass 10 million, it will be just 5. Then that is the difference, because here I have a maximum time that this can happen, and the maximum time that can happen is 5. And this one, the minimum time that can happen is 5. But the maximum, we don't know. That is why we always check the upper bound. What is the maximum time that can happen? And the maximum time that this can happen is 5. Never will be more than 5.
What if for the second function, maximum time it happen 100 times, for example, it's gonna be still O1?
Exactly. This will be 100, and this one will be 100. And as the rule we say, the numbers don't matter. Then this
Oh,
one,
okay, we know that number, right?
exactly.
We know, oh, okay, okay, makes sense, yep.
Now, what Kai told us, I think is very important. If you know the number or time that something is happening, pick over one, because will never be more. It will be 3 times, it will be 5 times. Then the time that takes is the time that takes. That will be constant, never more, maybe a little bit less, but never more. And when you don't know how many times something is going to run, then in this case, we have big O of n. And then we have it here. And this one is the other one that I told you?
So yeah, Mario, I have another question then, yeah, from
Yes,
this.
please.
So for example, we know that array has 1,000, I don't know, 1 million, so 1 million items inside, and we need to loop through. But for the array, it's gonna be O of n, right? Not O of
Yes,
1.
yes, yes, yes. Because basically it will depend. You are telling me there is
Even if
one
we know the
case.
number, it's gonna be 1 million times. We know that,
No,
but
no. That is what I told you. Here, let me just go here back because your question is is proving something. This rule won't always work. And your case is
oh,
not working. Your case is not
okay.
working because you are telling me that the array is fixed, will never change it. The array will have one time, then it's big over one. It's a constant time because that is a constant. You cannot change the array, then doesn't matter. I cannot do anything. I mean, I am fixed in that moment. In that moment, you just say it, okay? This is constant time, even though it's an array. That is what we have. And I think, thank you for the in this case for the example, and that exemplify what is really happening. If you don't have if we don't have this specific number, a rate of 1 million will never change, then I cannot do anything. That's it. And we have here constant time or local n, as I said. Sometimes they will be search big O n. The majority of time there will be objects and arrays big O local n. That is most of the time sorting, like when you put the thing in order. And big O of the square, there are some like a loop inside a for loop that we're creating. These are the most commons that we have. It exists more as you saw it here. Exists more here. And for example, here you will have it. Binary search, something, okay? There is, we have it. But the most common that you will have, and believe me, that there are even more of this, but these are the most common. And 95% of the time, you will be, this big over one is the optimal. We are always looking for this. But if you have something like this, that is cool. This is fine. We try to avoid this guide if it's possible. Okay, this is optimal. This is so good. This is fine. This is and this is okay. Let's try to see if we can avoid it. That is what we have it. And the space complexity. Believe me that the space complexity, I personally find it the most simple way to do it. But let's first define it, what is a space. A space most of the time is the memory that you are using in your computer. Why that is important? Imagine if you are saving something that is, you are creating an infinite array like the other one that we are creating, then you will need to have infinite memory. Do we have infinite memory? Sorry, no. Then because we don't have infinite memory, we have to take care about this one. You have to remember that when this computer science was developed, we didn't have all the computer were not as powerful as now, right? We have this very old computer with a small small memory or a small hard drive. Then every byte of the space in our system was important, but now not much. And the runtime there and the space time is just we measure in the same way with big O in this case. And you have to do we use big O notation to analyze the space complexity, and is how much additional memory do we need to allocate in order to run a code. In very simple word, how many new variables are you creating? Okay, how many variables are you creating in that case? Sometimes you will hear term auxiliary space, but the inputs we don't count it. Okay, we are not taking this in consideration. Technically, we will be talking about auxiliary space complexity that we have. The auxiliary space complexity, just showing you here, is this one, for example. This let total equal 1. We just need one element, okay? And do we need something else? No. Then the space complexity is 1 or constant. Why? Because a number doesn't matter how big is the number, it will be always one number. We don't have any inconvenience with that. And we have here, most of primitives, Boolean, numbers, undefined, and nulls are constant times. As I was showing you here, this is a number, this is a constant time. We have the other ones that strings require big O n. Why? Because actually the strings in JavaScript are a combination of letters, and every letter get a space of memory. That means like if we have a 25 characters, it will be a different than a 5 characters string, right? That we have it. Reference elements are usually big O n, and when we are talking about arrays and objects. Why we say it that they are big O n? Because an array can be n line, n big, can be like a 2 elements, or can be like a with 300 elements. It doesn't really matter. We have it, and an object will have, in this case, all the elements inside that and that are characteristic, right? Like we have, can be small, can be big. Then the size is flexible. That is why we call it big O n. And then we have it here. For example, here we have just one element. That this is one number. We have two numbers. Big of one space. What? This is a number. This is a number. The numbers are taking just one space. Space big of one number. Then and the second part, and that we have it. We have an array. An array in this case started with 0. How many? And saying push into the new array every element that we are having here. How big can be in that array? And why? Because it will depend on how big this element is, and we're seeing. Okay, this is n numbers. N numbers. Okay, we have n space. You see an array. An array will always be big over n for working purpose. Exception, and here goes Kai example. If I know that that array will be 1 million elements and will never change, then it will be constant time. Why? Because that array all the time, this function will always get one array of 1 million elements. You know what we have here? Okay, just to say it, we have encountered the most common complexities. Big over 1, big over n, big over 2. Sometimes big over expression is will have it, but you don't have to take attention with the more complex. I will be showing to you in the different classes. And for example, this one that we have it is just logarithmic. This is an exponential. Big logarithm of 2 is an exponent. We will omit the 2, and we will have log is equal to. Logarithmic expression are something a little bit complex. This is even mathematics. As I am saying, you say logarithm of 2 is just logarithmic, and logarithm of 2 here is logarithmic. When you have logarithmic of this one and logarithmic of this one, it doesn't matter these two, you say logarithmic. It's absolutely fine. Don't take it like you have to understand about this logarithmic or other expression. In computer science, they are very defined when we use it and how do we use it. We are not mathematicians, then we basically are using, we have a 2 for loops, then it's quadratic, then there is a way that we can optimize the information. We are not looking for perfection, basically. Okay. This is a division, what is called logarithmic because every time is in this case reduced. Logarithmic of 8 is 3. We have it 25 here, and this one will have it 4.24. Logarithmic time complexity is great. Yeah. Okay, there you have it. Why logarithmic complexity in this case is great? Because all the time, if you are seeing here, what you are seeing, logarithmic is when the problem can be divided between 2. And one of the most simple example is if you are looking something inside a bigger thing. First, this is a logarithmic. First, you divide it into the problem into the half. Then you divided the problem into the half. Then you divided the problem into the half. Then you divided the problem into the half. Here you just have your solution in this case. That is basically what logarithmic is doing. It's divided everything between 2 in helping you to arrive to conclusion. In this, in logarithmic, we will see something that is called binary search. But I have one specific class just to binary search. We have a problem here. We go to the middle, we find it middle, and just to find one element. It's also represented in this case that you are just dividing the problems into the middle, into the half. Okay, it's very cool. Who cares? Central, as I am saying, some searching algorithms have logarithmic type complexity. I mean, like they are very fast. N is in this case, don't think about recursion, and we will just have it like this. Even though I know that I have taken very lightly in some parts, I was just skipping it like a logarithmic and other one. I have my reason to do it for today. I want just to tell you that say that big O notation is using to identify problems into our code, mostly related with performance. When we say performance, how fast or how slow an algorithm will be behaving between that algorithm tend to go to the infinite. And Mario, why we're always talking about the infinite? For one reason. Remember that we have our system, we want to be used for a lot of people. Think about if the people from Facebook or LinkedIn or Instagram didn't think about the growth of they are expecting that their system will go to the infinite all the time. Then optimization is very important for them. That is why when you are interviewing for those big companies, you usually have this algorithm interviews. Why? Because for them, it's very important that the code is fast instead of other stuff. That is why they want smart people over there. Big O notation gives us a fast overview of space and time. You see an algorithm, and I hope that from today on, you will say, this is slow, this is fast, and this is fast. Okay, this is fast. But now I have this is slow. This is even slower. Why? Because I am multiplying the time of operation that I am performing. It's very important to pay attention into the number of operation that we are creating. Okay. The space complexity is important too. Why? Because you have limited RAM and everything. If you are saving in the same operation here, you can crash your code. Then we have it. Okay. Because notation is not about precision. Why? Because precision is impossible. It depends on your computer. It depends of, in this case, the system, and depend on many things. But we just need to know this is linear, this is quadratic, this is constant, in order to guide us where we are. The time or the space complexity not only depend of the algorithm, it's also depend on the hardware that we have it over there. And because notation is everywhere, guys. Because notation is in every single thing that you are doing, even in your life or everything, that you can just practice or go in like how many steps this take me to do it. Can I do it in less step? Can I optimize this step? Can I find a new way to do this specific step? I am seeing my code and I can identify where are the complexity into my code. And with the time, you will go over a little bit more. This one is basically just an introduction to data structure and algorithm. Why? Because in order to know that an algorithm or a data structure is the way that we have the data, right? An array, for example, an array, we can represent it in the real world. Just think that you are in the supermarket, and in the supermarket are different people over there standing one after another one. That is an array of people, right? That is an array of people that you have. Now, think about your family. You have your father, your mother, you have your brother, your sister, or everybody, right? And they have, in this case, different things. You have here, this is you have your mother, you have your father, and you have different, you have other people. This is called a tree. And then we are going so on with the different data structure that we have it over the elements. Okay. And that is basically what we have it about this part of introduction of Big O notation. And I would like to ask you, do we have questions so far? I know that we have a lot of questions, but I'm not sure if there is something specifically that you would like to ask me in this moment. Okay, I understand that part. I will suggest you. this is not working. I will just look for it. That aside of that, please try to go over these videos. I think is Timur who is going over this video. I don't know. Or that you can go over those videos and also read it, because maybe my explanation about big O notation can be not the most clear that you will find. This is the way that I understand it, how I use it, and how I be apply it in all the time. And as I said, when had been useful big O notation is most of the time in interviews for big companies. For small companies, not much, not much. But think about it, it's like a lifting weights. If you lift a lot of weight, your mind will be very sharp. I will say to you that if you want to train that one, you can go to HackerRank. Yes, practice 10 days. 10 days challenge. And this is a very 10 days of JavaScript. This one is a very good initial challenge that you can take it. That is 10 days to JavaScript. You log in and okay, I will just log in with something else. Okay, and here they will just, there are 30 days of code, 10 days of JavaScript, and you join it, and here you will have the different code. This one is a very good introduction to the algorithm and data structure. It's not that complicated, but you can go every single day. You will just open it and you can read it. Here you will be practicing. Another place that you can do it is LeetCode. I will not suggest you right now to start LeetCoding, but it's also another way that you can just go over it. And I will just log in with this, you guys, sign in. Oh, okay, no. I don't. You can just go and you can go here the problems, and here are the different problems, and you can find the difficulty, easy, and the type. Interview question for the different companies that we have it. It's another good way to be practicing what we have it. And here we'll have a binary search and everything that going over there. If you want to know, for example, more about arrays, this is a very good place to go. I think that there exists one, this one, and you will learn everything that you need to know about arrays that you have it. If not, if you are not that interested in competitive programming, or at least at the beginning not thinking to go by Facebook, stay with me and we will go over this one. We will go to analyze problem, solving problem, recursion, searching, slightly linked list. We will also see trees, and if everything goes well, I will also be I will also checking backtracking, searching, and another algorithm that we may have it here. This is not the most easy class, but I hope that you will enjoy this part. The class is basically over right now. What I have prepared for you. If we see our now, okay, we go about big O notation, space complexity. For algorithm, we already covered. We already saw from promises and assign away. Then we will take, I'm not sure we will have to go over the practice. And the first thing that I always ask, there is any exercise that you have been blocked so far? How we are going over here? For example, Ian, are you working in this practice question here in the portal so far?
So far I even didn't start it, but yes, I have to. Yeah. Sorry.
Yes. No, it's okay. Okay, just let me take some note. These notes are for me, okay? Because this is important for me, okay? And Isa, how you are here over there in this exercise? Are you blocking some place? Where are you right now? Okay. Amantur, where are you?
I'm on the question 60. For now, it's going good.
Okay, that's good. Aisada? Joanna?
Hi, Mario. I finished junior questions and I need to start medium questions.
Oh, wow, okay. That is great. That is great. Okay. Kyle?
Yeah, I completed medium questions and I'm going to start algorithm questions somewhere soon.
Okay, I don't have anything to say on that. And Sarina?
I'm working on making on junior questions. It's 20 minutes, I think.
Okay. Okay. No, basically we don't have any question. Well, I don't even see like I will have too many inconvenience over there. Okay. Hey. I say, okay. I am a junior question. Okay, we are okay. We're pretty well. Then basically I will just go here. Okay. Then I will forget about easy question, honestly. I think that there is not much to um I'm sorry, if I ask you a question. When did you join to the cohort or something? Just to know. You joined it late or any inconvenient over there? Do you have any inconvenient, for example, with for loops or for if or all those stuff?
I have some problems with reduce.
Okay, that one we can cover it right now. It's absolutely fine, Serena. Okay, okay, I can cover reduce. We have some time. I can cover the reduce. If any other commentary that you would like me to go over it, we still have like a 15 minutes more. I can go over reduce. Something else? Okay. Mhm. Let's go over reduce. I will just send you this information here. May be useful, and I will just go to it. Reduce. 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 Okay. We know that we have this higher ordered function. They are basically arriving from all the arrays. From the array. Let's say that we have an array. We have most of the time we have an array, and this array have different elements, right? 4, 5, 6, 7, 8, 9, and 10. A reduce it is called the transformer. Transformer. Why? Because get an array and transform into what you want. It doesn't matter. That is the same. Let's say it. The easy way to see this one, let's get the sum of all the elements. Okay, const sum equals, and you say dot array, and you go to reduce, right? Reduce get a callback function. Okay, here is the callback function. Here is the callback function. And get, in this case also, what in this case is the initial value that we will have it, 0. This callback function that we have here get 2 elements. Which element get? Look, here, the previous element, and also get the current value. And the current value. What is the current value? That is something that we have to know. All these functions, what they are usually doing is iterating element by element. It's just iterating element by element. The current value is, in this case, in the first iteration is 1, in the second iteration is 2, and the third iteration is 3, and so on. So it's the only thing that are doing the higher order function. Map, reduce, for each, search, wherever. They just do like that. They are basically one for loop that they are going element by element by element by element. They are not doing anything else. Okay. But the reduce has one characteristic. The reduce is calling itself. After every operation is calling itself. But we need an initial value. Okay. And what is the initial value? The initial value will be 0. Okay. Then this one, basically, that you see over here, this one is 0. That one is the 0. This 0 that you see here is the previous value that you were having. Okay. Then you say new value. Let's say new value. Let's say it const new value will be equal to the previous value plus the current value. Current value. I will do it in singular. What is the previous value? The previous value is 0. And what is the new value? The current value? The current value is 1. Because that is what we have it up here. Okay. But this function would call itself. And in order to call itself, I have to return. And what I have to return? I have to return the previous value. Then I just say return new value. Okay. And you know what is happening? What this function is doing? When you return this new value here, and this new value here, pass here. Now this new value is 1, and this is return again. The new value is 1. The current value is now 2. I hate this to have this thing here. Okay. Now you have it over there. Now that you finish, now this one is 1 and the current value is 2. The previous value is 1 and the current is 2. then new value is equal to 3. Then this 3 pass here. Then this 3 pass here again. And the new value is the number 3. And that is the only thing that is repeating. Why do we need in this case and then this case this extra value? Because in this extra value is where we are sending our response. Then our response is entering here, and it's just getting element by element. And we just go here, console.log, and you say sum. Okay. Then it's just summing the element. This is one way to use it. But I say this can get anything. Let me just say, I will just say cons sort. Let's say like a group by, let's say it even and none. Okay, none. Okay, even and odd numbers. Okay, even and odd numbers. Even and odd. Even and odd. And odd. Okay. What I want right now is to return one object, and in every object I will have even some element and odd in another array. This is what I want to return. Look, this is what in my brain I want to do it. Okay. Then I take my response, that is my array, I just with the reduce all the time the same thing. There is nothing more that is needed. But now I will pass an array and an object. Okay. And in this object, I will create two elements. This one will be even, for example, and it will be an array, and the other one will be odd. And you know what? It will also be an array. Here I will have previous, and here I will have the actual value. And I will evaluate. If actual value, in this case, modulus 2, what happened if I pass 1 into modulus 2? It will be an even or it will be an odd number. Someone can give me a hint? Or it will be an odd number. Thank you so much. Then I just say, okay, previous dot odd dot push, and you know what? I will push the actual number, and in the other one I will say previous dot even dot push and actual number, and never forget to return I will just return the previous, right, that I am having here. Now I will just say console.log group by even or odd, and you have it here. This one doesn't exist, right? Console log, that is something weird. And then there we look. Here we have the answer. And it just gives, these are the numbers that are even, and these are the numbers that are odd. That is why they've reduced. You can just do everything. You can just create another object, you can create another array, you can create whatever you want. It's just a transformation. The most important part related with reduce is this. What you declared here, it will be your response. If I declare an array, it's because I want to get an array back. If I declare a number, it will be a number. Or if in an object, it will be an object. That's it. The previous one is what you are returning. This is the initial value. And all the time we are modifying that element. And this accumulator is nothing more than a simple for loop that is going one element after another element after another element after another element. I'm not sure is this makes sense a little bit more. Sarina?
Yeah.
Okay.
Thank you
cool.
very much. We can use everywhere, and actually it's like looping, but we have also additional this part where we can type, for example, we need object or array. Yeah, we don't need to create another variable. We can just do it in this reduce.
Exactly. We can just use it in this reduce. And I will say everything that you are doing into this higher order function are basically for loops that you can easily create with a function and create a one for loop. Just they are comfortable. That's everything. There is no more. Less line of code, you reduce some time, but there is nothing more than that. Do we have any other questions? Okay. If we don't have any other question, I didn't give you the second break, then we will finish today. I am just going over here related with everything that we have seen. Next week, we will start working with an algorithm. That is the way that we are going to solve a problem. If you want, in this case, you can review pickup notation. No, sorry, this is what we saw here. You can review the part of analyzing, and we will just talk about data structure in this case. What is how to use object. We will just see insertion, removal, searching, access, and arrays. That means like next week, we will just check it objects and arrays, just in case if you have a question, right? And feel free to watch the video before arriving in the case that you have it. If not, it's absolutely fine. Thank you for staying here. And
Thank you, sir.
Thank you, Mario.
you're welcome.
Thank you, Mario.
See you next week.
Thank
Thank
you,
you.
Mario. Yeah.
Thank
Have a
you.
good day.
Welcome. Bye-bye.